Okay, hi all. Okay, so what we're going to do today is we're going to do gas welding, or oxy-acetylene welding, using two gases, oxygen and acetylene. They just call it oxy-acetylene for short. This is basically your old school original type of welding where we're using a flame to actually melt the metal, and then you see it melt and you see it join together. There's a few different types of welding, which I'll go over in a bit. So that's what we're going to start on. I like to teach everybody oxy-acetylene welding before we go into any other types of welding like MIG, TIG, or stick, because it's a slower process. You actually get to see it happening, and it makes you a better welder across the board. In the future, you may end up using primarily MIG or TIG, but this really gets you to be a little bit slower, more fine-tuned. You get to understand the concept of what's happening. Where some of the others are just MIG welding is a little bit more point and shoot. So it gets you to slow down. But before I get into the tanks, I'll talk about metal a little bit. So what we're going to be using is mild steel. It's regular carbon steel. There's mild steel, medium steel, high carbon steel, and that just refers to the amount of carbon that's in the steel. Mild steel has about I think 0.18% carbon, and it makes it easier to work with. So you can like heat it and hammer it and do things to it where it doesn't get so brittle. The more carbon that it has, the more brittle it will get from heating and hammering. So it's a good metal to work with. And now just to show you, what we're going to do today is we're going to do some practice welding, and we're going to use, this is flat bar. This is 1/8 inch thick by 2 inch flat bar. And when you refer to metal, you usually refer to the thickness of metal in gauges, okay? So this is about 11 gauge. 11 gauge or 10 gauge is approximately 1/8 inch thick. And gauges don't really, it's a made up number. It doesn't refer to anything. It's not like a fraction or anything. It's just, you just learn that separately, what gauges are. The larger the number, the thinner the metal. So a 22 gauge would be pretty thin metal. So like I said, approximately 11 or 10 gauge is 1/8 inch. And that's a really nice thickness to learn welding on. If you go thinner than that, it starts to melt through and it's very frustrating. So, and then until you're better at welding, you shouldn't go to thinner metals, okay? So we'll practice on this, but just to tell you some different members. So like I said, this is flat bar, and flat bar can be anywhere from maybe 1/2 inch wide up to 12 inches wide, and it's just flat bar stock. After 12 inches, you would get into sheet metal. And this is a section of sheet metal that some of you worked on last week and the week before. So sheet metal usually comes in large sheets, like typically 4x8. You can get it in other sizes like 5x12, 4x10, but typically what the metal places have in stock is 4x8. So that's sheet. And then once you get up to different thicknesses, like this is 1/8 inch or 10 gauge. When it gets thicker than that, like up to 1/4 inch, you start actually calling it 1/4 inch or 3 inch, 3/8 inch plate. And then other things, there are tubing. Tubing is anything that's hollow, okay? Round, square, rectangular. So that's all tubing, okay? And then tubing is called out by its wall thickness. So you can get the wall thickness in different sizes as well. So tubing is anything hollow. Flat bar is anything up to 12 inches wide. And then there's angle. And angle is just, we're dropping everything. Angle is just 90 degree, okay? So anything that's 90 degrees is angle bar. And then there's solid bar. And that's anything that's solid. And again, it could be any size. It could be round, square, rectangular, but it's solid. So that's some different types of metal that you can work with, or if you have projects, you can think about what you might need. So now to talk about the welding setup. So we did cutting already, which this is a cutting torch. For those of you that missed the cutting, we'll go over that again at some point so you can have a little exposure to it. But for welding, we're going to be using these small tips, okay? And the welding tips come in different sizes. They just have one hole in the top, and the different sizes you'd use depending on what thickness of metal you're using. So there's numbers, like this one is a 00, and you can find the number on the base of the little torch tip. And usually they have it in 2 places, but these are really new and they don't have the number in a second place. Okay, I'm rambling. So anyway, 00 is small. It goes down to 000. And then 0 gets a little bigger. 1, 2 is what we're going to be using typically for 1/8 inch metal, or 10 or 11 gauge, okay? I keep saying 10 or 11 gauge because 10 gauge is a touch bigger than an 1/8 and 11 is a touch smaller than 1/8, so it's about the same. Up to number 5. And then the other thing, so with this setup you can weld, you can cut, like I said, this is the cutting torch, or you can also heat up. This is called a rosebud. It's a little bit larger welding tip it looks like, but it's not for welding. There's several holes in the front, and it's just for heating a larger area, so you can actually form if you wanted to form, like blacksmithing. So basically you can accomplish a lot with just the oxy-acetylene setup, which is contrary to other types of welding. You're just going to be able to weld with the other machines. You can weld, form, cut. I had mentioned before that if the smallest metal shop, if you want a metal shop, the least expensive, all you need is an oxy-acetylene setup and an angle grinder, and you could pretty much accomplish everything that you can accomplish like in a fully loaded shop. It may take more elbow grease and more time, but it will be less money, and you can get it all done. And in the beginning, it's really fun to do it that way. So the first thing we'll do is I'm going to talk about the welding tip. Let me put all those aside. The number 2 tip. You always want to make sure that your tips are clean, because after welding, some soot and buildup will develop. These are older tips. See the difference? So there's always a little file set up in the back of the rig. And there's little files in here, little cylindrical files, and one flat file. So you find the cylindrical file that fits in the hole the best. You don't want it to be too small or too big, because then it ruins the integrity of the welding tip and it will mess up your flame. So you find the one that fits the best, and then you just clean it out. Every time, I always say do it when you're done. No one really does it when they're done. Just do it before you start them, okay? And then there's the flat file that you'd go across the top of the tip with, and try and stay as perpendicular as possible, because if you start rounding the edges, that also affects your flame. So you just want to keep it in good condition. And the tips are copper, so it's a very soft metal, so you can file it nicely. And always remember, because it is a soft metal, to be careful when you're placing it down. Don't drop it on the floor, because once they get banged around, the shape will change, and again, affecting your flame. So that's the tip. We're going to use the number 2. And this is our setup, okay? Oxygen and acetylene. So they both have regulators. These are regulators on top. This little gauge here, the one on the right, refers to how much gas is in the tank, and the one on the left refers to the pressure, the suggested pressure that we're going to be setting it to, depending on the size tip and the thickness of metal that we're welding or cutting or heating. So we'll open those in a sec. Usually there's a long hose on your setup, and I like to let all the hose out so that I can move my tanks far away from where I'm welding, just for safety, okay? If there should be a leak, even though we check for leaks, and you have fire, you can have potential flame or fire explosion behind you, and you don't want to do that. So I usually let out my hose, and I try and make sure it's not like underneath my feet. You want to be really conscious of where everything is so you're not tripping on it and knocking things over, okay? It's really good to be extra safe in here. Don't come hungover or tired. Just come the next day then. This is the torch handle, and there's always a protective nut on the top, okay? And all this does is protect the threads. Because it is a soft metal, they'll get banged up. And if they get banged up, then again, you have potential leaks. And it's also a soft metal so that you have a really nice tight fit. You don't have to go crazy. You don't need a tool to tighten it. It's always just like 2-finger tight, okay? And that'll be tight enough. I usually position it, although most of you remember from last time, they were so loose. But I usually position it so that the knobs are on top and that my welding tip is facing down, okay? And these should be shut off, so I'm just double checking that they're shut off. If these aren't shut off, when I go to turn on the tanks, the gas will start running out, and that'll affect my pressure. So those were left on. I usually find a comfortable place to set my torch so that in between welding. I like to hang the tip off the edge, again, so it doesn't get banged around. So now that I have that tip on, I'll show you how to set up the tanks. So for welding 1/8 or 10 gauge metal, we'll say 11 gauge because I like odd numbers better, so we're just going to call it 11 gauge from now on. For welding 11 gauge metal, we're using a number 2 tip, and the pressures that I use are 5 and 20. Okay, that's 5 for acetylene and 20 for oxygen. And you can read in books, pamphlets, or wherever, different suggested pressures. This is the pressures that I like to use after welding throughout the years. I find that that's like the smoothest welding for me. You can bump it up a little or down a little as you get to know it, and then you can see the difference in the flame where you can feel it out. It's good to get to know the flame, but 5 and 20 is nice. If you have the acetylene on too high or low, sometimes as you're welding, you'll get this loud pop. It'll just turn off a lot and scare you half to death, and you'll drop the torch. You're not going to drop the torch. If you get scared, just stay calm. Okay, so opening up the tanks. First we're going to open up the oxygen all the way. I'm going to make sure these are loose. A lot of times when people are in the shop, they'll use it and they'll leave the pressure set, which is what happened, because they're coming in the next day to do the same thing. But I always like to shut everything down so that we can start new, and then it's not getting used every day. It might not get used till the following week. So if you leave the pressure set on this, it could actually put wear and tear on the gauges where they don't read correctly. So we'll always bleed the line and shut everything down. So to start again. Okay, we're going to open the oxygen 100%. This needle went up already. Tells me how much I have in the oxygen. Now, in order to set the pressure on the oxygen, on both of them, we're going to tighten this, okay? So that's the difference. Like usually you think, oh, I have to open something lefty-loosey, but in this case, we're turning it to the right. You tighten this one. You start to hear the gas come out and the needle move a little. You can go slow. So I'm going to go up to 20, which is the first red arrow. Now, if you happen to go too far, you can't just lower it. The needle won't come down. You'll have to bleed the line. And then it comes down and you can go again. So that's at 20. Now for the acetylene, I don't open that up all the way. I just open that up maybe like a full turn and a little bit, and that's for safety. This is the flammable gas, okay? Always remember that this is the flammable gas. So if somebody does catch on fire, which you'll always be welding in pairs, try not to come down here alone. Always bring someone with you, even if they're working on something else. It's just safer. So if one person is on fire, the person that's not on fire is going to come and cut the source, okay? So that's easier off. So and you don't need a lot of gas on to get the flame. So I open that up like one turn and a little bit, and then I'm going to set the pressure to 5. Okay, there we go. So now it's 5. Now we're ready with this. Just like that. And I'm going to go ahead and just move this back a little bit. When you do change out tanks, and there'll always be somebody doing it for you probably, but just to know, we'll use like a little water that has a little bit of dish soap in it. We change out the tanks, put the regulators on, and then you spray it, and if it bubbles, then it means there's a leak. So you always check everything for leaks before you use anything. Okay, so welding basically is joining two like metals with a filler rod, which is also the same metal as the base metal, and making it one. So if you guys, I know some of you guys solder and braze. Soldering and brazing is different than welding because your base metal is going to be a different metal than your filler. So your base metal usually has a higher melting point than your filler, so your base metal is just getting warm where it's opening up the molecules, and then your filler is melting and like grabbing into the like capillary action, so it's holding it really tight. It's a good connection. That's different than welding. And then soldering and brazing is really, the difference is the temperature. I believe that anything under 800 degrees would be soldering. Over 800 you would braze. So sometimes we braze in the metal shop. You can use steel and use bronze brazing rods to braze and hold it together. And sometimes that's nice to do just for the look too, because you'll have steel and then your seams will be in a bronze color, and that's kind of nice. But this is welding, and welding is always same metals, okay? So same metal, same melting point, everything's melting and joining together. And what happens when you weld, sometimes you like lose material and it ends up a little concave, so you want to use a filler rod to replace that metal and make sure that it's strong. And filler rod also comes in different thicknesses. So we have a 1/16 here, and then there's 3/32. I usually use 3/32 when I'm working with 1/8 inch metal. And sometimes you don't need it, but we're going to be welding like really clean, straight edges here. If you're sometimes you're welding something that's a little wavy, or holes. You can fill big holes too. So you'll want to use more filler rod in that case. And this just has a copper coating to help it not rust. It's very thin, so that melts off right away. So like copper, bronze, I think their melting point is roughly 1800 in the 1800s. And steel is 2900. It's not an exact number, but it's around that. So it's about 1,000 degrees difference in the melting point. So this little thin layer of copper, that's just gone. So actually, I need a magnet. Wait, here's a magnet. I usually have a magnet because when you're wearing your gloves, it's really hard to pick this up. So this way you can pick it up. If you're a righty, I weld with my right hand and hold the filler rod with my left hand. The first thing I'm going to do is I'm going to show you how to melt the metal and do welding on a flat surface without the filler rod. We'll add that later so I can make it more difficult. Another thing to keep in mind, before I join these, I'm not going to join these two right away. I'm just going to practice melting the metal, and then we'll see it puddle and show you basically how to weld. But if I keep this piece on this flat surface, it's going to want to heat up the whole, because this is steel, it's going to want to heat up the whole table. It's going to take longer. Your table is going to end up being a lot hotter. So what I do is I usually find angle bars somewhere that looks like about 1/4 inch angle bar, maybe 3/16 by 2 by 2. So I raise it up. Okay, so now that's going to work out better. I only have these points here that are going to act as a heat sink, and that's not too bad. So usually I raise it up. Now we should get ready. Does everybody have their goggles? And the level of protection for gas welding is level number 5. So I know like everywhere, like out in the world, you always see people wearing these helmets for welding, or this really nice old school one here. And then, but that's for MIG welding and TIG welding. So for gas welding, and this is like a level 10, between 9 and 13 actually, and the number just refers to the darkness. So you put this on, you really can't see through it. But with the level 5, you could still see through it and it protects your eyes. So just to be ready with them, we don't have to put them on yet. So what I'm going to do is I'm just gonna heat up a little puddle. I'm gonna wait, we're gonna see it. You guys will all come in closer when I start to melt. But with my flame, it'll get a little glassy and then it'll start to melt. And when I actually see it turn into liquid, then I'm gonna start pushing the liquid. So now think of it as a liquid, not this hard metal. And there'll be a gas pressure coming out of your torch, right? So with that pressure, you'll be able to push the liquid where you want to push it. So we have a puddle, and then we're going to be welding from right to left, except for the lefties. Well, there were a couple. Okay. And then we're gonna push this puddle to the left, and we're going to make these like backwards C shapes. Okay, so it'll become more clear what I'm talking about once I do it, but I just want to run it by you before I do it. We're going to be pushing our puddle to the left like this, just like this, and I'm exaggerating it. Obviously that's much bigger. And we'll be pushing it to the left. We won't want to go too fast. If we go too fast, we'll lose the liquid puddle and it'll be very much on the surface. So we want to try and keep the same size puddle, and we just push it to the left, okay? And what we're going to do is we're going to practice, all of us, we're going to practice doing some of these welding lines on the flat surface. It takes a little bit more patience and it's a little bit more difficult to practice these welding beads on a flat surface than when you weld two pieces together, which we will do also. But that's good practice to get used to it and get the patience down before you start welding a couple pieces together. So to back up a step to tell you how to light the torch. We have our pressure set, 5 and 20. I talked about that acetylene is the flammable gas, and not to forget that. And there's clues. The red hose, I always think of red fire, okay, so flammable. It usually says flammable gas right on it. And if you look on the torch handle, it says fuel and oxy. So it's everywhere, okay? So that's important because if you turned on your oxygen and tried to light it, it's not gonna light. So you have to always turn on your acetylene first, light it with your striker. We're gonna adjust it again to another pressure by sight and sound. And then once we get that looking how we want it to look, we slowly add oxygen until we get a neutral flame, which I'll show you how to do that also. Also, one thing I want to mention is the gauge on the acetylene only goes up to 15 psi. Oxygen goes up to 200 psi, but after 15 psi, acetylene becomes unstable. So there's a few things in this tank, like weighting it down, and absorbing the acetylene and weighting it down to the bottom. Well, after 15 psi, it becomes sort of volatile in there, and everything's bouncing around. Another reason why you can never ever lay this tank on its side and then lift it up and weld with it right away. You'd have to wait at least an hour. I usually wait like a day, but because it becomes volatile and unstable. I've never seen it happen, luckily, but So maybe it blows up, I don't know. But so we won't ever go up to 15 even. We'll use 5. We might use 10 at the very most if we were using the rosebud. And even with cutting, we only put it up to 7, okay? So what I'm going to do is I'm going to turn on the acetylene first, just a tiny little bit. You don't have to turn on really high because like your gas stove, if you turn it on too high and then you light it, it's like poof, right? Lose some eyebrows or eyelashes. But now they have all kinds of things for that. It's fashionable. So I'm going to turn on the acetylene a touch. I'm going to light it. I'm going to increase the acetylene to be the pressure by sight and sound that I want it to be. And then I'm going to slowly add oxygen. But this is what's going to happen. We're going to have, here's the tip of our torch right here, okay? So the acetylene's going to be coming out here. And then as we add oxygen, you're going to see this little white cone right here, and then like a long feathery whitish inside, in front of it, okay? Another like feathery cone. And as I increase the oxygen, this feathery white cone gets shorter and shorter, and you want to keep increasing it until this cone exactly meets this cone. And that's called a neutral flame, okay? And that's the flame that we need for welding. And a lot of you did that with cutting last week, okay? Once I get that and I get the little cone, then I can start heating my metal. And you never want that cone to actually touch the metal, okay? So we're going to stay just above it, okay? The further you go away from it, the larger of an area you're going to heat up because it's sort of conical shaped. So we're going to stay fairly close because we really just want to heat up the spot that we want to weld, okay? And inside the cone here, that's the coolest point in here. So we don't want that to touch the metal. This right here is the hardest point. Okay. So I like to put on one glove only while I adjust my pressure. You don't want to over tighten these because there's these little plastic discs inside here. If you over tighten them, they crack, and then the knobs become very loose and flimsy. How they were last week, but we fixed it. Okay. Okay, so just a little touch of acetylene. I'm turning the tip up like this because I want to be able to hold my striker away from me when I strike. I don't want to strike like this because I lit it. Didn't mean to do that. If it's on too high, you know, the flames can come back at you in the face if it's accidentally on too high. So I turn it like this and light that way, okay? So a little bit of acetylene, okay? Now turn it back around. Now I'm going to show you, like, that's too soft of a flame. That's like a really flimsy flame, and that's all carbon, all the black soot. You can draw with it. I've used it also like to help darken my patinas with oil and stuff. Now that's way too high of a flame. You could hear it. It's too strong. When you get a gap like that, that's too much acetylene. You want this medium to strong flow. Like that's about nice, right there. And you can see you have this sort of straight bulbous area before it splays out, maybe about an inch and a quarter for the size of that straight area. But it's a medium to strong flow. And again, you'll get to know this better as you weld. Just having this up a little or down a little will change your weld. And they'll both be fine, but you can tell the difference, and so you'll see where you like to put it, okay? So everyone's goggles are on, and we're going to slowly add oxygen, but I would move in a little for this so you could see it. Hold on. All right, can you guys see that there's and can you see the inner cone too? It's like a little white line. Until they meet. Now one thing I want to actually show you You see how that inner cone, it's like got two parts to it right now? That means the tip is dirty. So I'm gonna turn it off. It's a brand new tip, it hasn't been used, but maybe there's just a little buildup in there. So whenever you see like, if your flame is like separating and making two halves, it's dirty, stop and clean it out. So there's like a lot of setup before you get to the fun part, but that's how it is. Let's see. This one looks good. What? I bet these are over 20 years old. Yeah. No, there's no doubt these are over 20 years old, yeah. I think they were here before I was here, so. Alrighty. Boom. Medium to strong flow. Goggles. Slowly add the oxygen. Okay, see that? Now our long feathery cone is nice and pointy. It's not splayed into two pieces now. I'm slowly adding it, slowly, just until they meet. And now I have a neutral flame. Now here's the thing to remember. Don't hold back here because as I mentioned before, it's sort of subconscious. You're like, I want to stay away from that flame. But you need to hold up here, okay? So I'm going to slip my gloves on. It's no problem being close to the frame. I mean, you're not going to hold up here, but like, this isn't hurting me, okay? So you're going to hold here. You're going to be aware of the knobs. Now, I would come up a little closer if you guys can, so that you can see the color change in the metal, and then and how it melts. Okay. Oh, and I didn't mention, but I like to make sure I'm always very comfortable. I sort of stand like with my legs separated, triangular. Elbows kind of tight, and I like to keep tight so that I can stay a little steady and controlled, okay? If you're like welding out here, it might be messy. So same thing with cutting, you know? So I just try and get in a like nice, tight, but comfortable position. I'm aware of my hose. The worst thing that happens is because of the angle of the torch, you're lifting your elbow up like this, okay? I'm gonna leave that flame on, but so what you wanna do is, okay, since it's not a 90 degree, right? And we wanna weld from right to left. If I just stayed like this with my elbow down, whatever's right in front of that cone is gonna get the hottest, okay? So if I stay like this, I'm gonna heat up this way, but I actually need to go this way. So you wanna get on the proper angle, and that's like lifting your elbow up in an awkward position. So your torch tip is angled in the direction that you're going, so that you're always heating up the spot right in front of it, but it also has to be kicked up this way so that you can move from right to left. You understand? Okay. Gloves back on. I lift the goggles up because sometimes I feel like I can't talk if I'm in the dark. Okay. All right. Okay, so the first thing I'm going to do is I'm going to stay fairly still in the same spot. I'm not like trying to heat up like a large spot like that. I'm staying still as much as possible. The color starts to change, and it's going to start to get a little glassy soon, okay? You see it starting to melt, everyone? But I'm still staying here because I want to get that puddle a little bigger. okay? A little smaller than dime size, okay? Now that I have the puddle, I'm pushing it slowly to the left. Remember how I made those exaggerated backwards C or horseshoe shapes? Sometimes you can hardly tell that I'm making those shapes. That's why I drew them bigger. But that's what we're doing. We're kind of, think about it as stitching, okay? We'll draw a line, a straighter line than the ones I drew, but we'll draw a line, and you think about stitching on either side of that line. Now, if I move too fast, see what happens? I've lost my puddle. It's only this tiny little thing, and that's not going to be welded well. So I'm going to back up. I'm going to get that nice puddle again, and I'm going to slowly go to the left. And your speed, honestly, is just dictated by how hot the metal is, how thick your metal is, how hot or cold the day is. It just determines how fast it's going to melt. What I missed part of that because it's loud right over.
Do you mean that the C shape is like the motion you're making with the torch?
Yes.
Or that's just how it...
Oh, okay. Yeah, no, that's the motion I'm making. So I start here, and it's like small, and I don't know if you guys can see that I'm moving. Is it minute? Okay. So I have the puddle, and this is what's happening. I have the puddle, and I'm pushing it like this. Okay, that's my line that I drew right here. And it's like I'm stitching around that line. So it is small, but it's like this. And so I'm pushing it. Again, just think about liquid, and like if you had some kind of air, you know, you can push a drop around. So you think about where you want that drop to go, and that's how you position your torch tip, and you push it, and stitching like this. But yeah, sometimes as you're doing it, it actually is a lot smaller than you think. That's why I exaggerated it. So what I'm going to do is I'm going to start back here. If ever you're in the middle of welding and you should stop, like here's my last bead right there. You don't want to start to the left of it. I usually start right back on the last bead, get that melted again, and then go so that you have a nice continuous weld. When I get to the end, the end of the metal right here is going to be the hottest part because I've just spent all this time heating the metal up. And what will happen sometimes when you get to the end is you'll actually burn through the metal there if you stay too long when you get there, so you'll end up with the metal looking like that. So what you do when you get to the end is you want to stay near it, but I actually take the flame off of it and just leave it right above because that keeps that gaseous environment over it, so it protects it. If you move this away too fast, you get these little pit marks in your last weld because the air from the environment affects it rather than having the protective gas right around it. So what you do is you lift it like this, and you can actually see the color die down. It cools a touch. You lift it like this, you see the color die down, and then you move your flame. And I'll repeat this stuff a lot, and when everybody's doing it, you guys are going to see it several times. So all these things that I'm rambling, they'll sink in and be repeated. Okay, so I'm going to light it again, okay? So a little bit of acetylene, holding the striker away from my face. Now setting the pressure by sight and sound to a medium to strong. That's nice. Goggles. Slowly add oxygen until we get a neutral flame. There we go. Now, if you exceed that point, you go further, that's going to be too hot, and you can hear it too. You don't want that. You want them just to meet. Okay. So I would start back on this last bead. I'm staying still. I'm waiting for the color change. I'm going to wait again for it to get glassy. It cools off fairly quick away from the melting point, but it stays, the metal's still too hot to touch. Okay, it's starting to get in a little glassy and a little liquid. Okay, now we are getting a kind of a nice puddle. All right, now I'm going to start moving, pushing that puddle slowly to the left. You'll notice right over the angle bar where it's touching the other metal, it might sometimes have a little heat sink in that spot and take a little longer to pass over that spot. It really wasn't bad, but sometimes that happens. Okay, so now I'm getting to the end, right? That's it. Okay, you want to turn your oxygen off first and then your acetylene. If you remember, just the hint to remember how to turn on and off the gas, it's goog, it's gas to light it, add oxygen, and to turn it off, it's to take the oxygen away, and then the gas. So, is it on fire? Okay, thank you. So, see, it's always me that gets hurt. It's never the students. Thank you. So, goog. On gas, oxygen, oxygen, gas. And the reason why you're adding the oxygen to the gas is it makes it a lot hotter. It accelerates the flame. And you need that to melt the metal. And so turning it off, you're taking it back down. And then the gas. Okay, so now I'm going to do another row or another welding beads, line of welding beads. But I'm going to add filler rod. And this is what I'm going to do to add the filler rod. So we have our puddle to start off with, right? I need an eraser. One second. Yeah, that table's just for cutting, and it's very uneven and bumpy and lower, and it's just nice to have a flat surface, even though this isn't really flat. You need it to make something square. It's not flat. Yeah, that's just for cutting, and it's kind of messy and not comfortable. But I would do all my work on like a big flat surface like this. So yeah, that can be a problem. Not for me because I'm short, but if you need to raise it up and you're more comfortable, you can do that. But also what I do a lot is I sit when I weld, gas weld especially because it takes longer. MIG welding, I don't usually sit. It's a little bit more dangerous. There's more sparks that fly with MIG welding, but with gas welding, it's a very slow, really meditative process with the flame. I usually sit. You just want to be careful. You probably want to wear an apron in that case, because when you are sitting, little sparks could fly in your lap and burn you. The other thing is it gets really hot. A lot of times when I'm gas welding, I'll wear just a long sleeve cotton shirt or army jacket and wear the apron over it, and you don't have to wear the big heavy suede jacket because it can really get hot, especially in the summer, and you're just sitting over fire. So with gas welding, that's safe enough to do. With MIG welding, no, you're going to want to be covered in leather because if you just have on a cotton shirt, you just have a lot of little holes in the shirt and your arm. Okay, so filler rod. So I'm going to do the same thing. I'm going to make a little puddle. I'm going to do the same motion, but this time I'm going to add a drop of filler rod every couple beads. Okay, so there's a puddle. I'll start pushing that puddle a little bit, and then right here I'll touch the outer perimeter of the puddle with the filler rod while I'm still aiming at the puddle. A real common thing to do is when you add the filler rod, you want to move the flame, but then the filler rod won't melt, okay? So you make the puddle, this is the cone. You're aiming at the puddle still. You touch the outer perimeter of the puddle. I may just lift the cone up a touch to aim right here, but still staying over the puddle. Because if I move away, the puddle's gonna just get cooled and you're not gonna have a puddle anymore. So you do wanna stay there. touch the outer perimeter, slightly aim at it. You'll physically see a drop fall into this puddle from here. And then you move it away, you go a couple more, and then boom, you do it again. And you want to hold this away because this actually melts so much faster than your metal. So I'll be sort of welding along. I'll have this out here. When I'm ready to add it, then I'll bring it in, touch it, aim, the drop falls in, boom, and then you go. Okay?
How do you know when to put the rod in?
For the sake of practice, we're just going to do it every couple beads. But when you're welding along, like if you have a space or a gap, you may add more filler rod. You're going to want to, since we're using like pretty straight edges here, we're going to consistently put filler rod, because what'll happen if we don't put filler rod, this will be very flat, even possibly concave, and that'll be a weaker weld. So since this is sort of shaped like this, right, we're going to be welding like this. If we just welded this without filler rod, this tip would kind of melt off and this would melt off, and we'd just be using this much to weld. But if we add some, we just end up with more of a surface, more material to hold it together. Okay? Okay. So, lighting the torch. Ready? A little bit of acetylene. Holding the striker away from me. Medium to strong flow by sight and sound. Goggles, and slowly add the oxygen until we have a neutral flame. Okay? Slip on my other glove. Now this is where you also have to learn how to get balance and control. Because when you're welding without the filler rod, I often use this hand to kind of help me stay straight. But now I have to take this filler rod and hold it with my left hand like a pencil, okay? Okay. I don't know if you can tell, but the acetylene was a touch less this time than last time, so it's a little quieter. The point is a little smaller, and that's fine. I'm just pointing it out to see if you could, if you notice. Okay. Starting to get a little puddle there. And I'm going to start moving to the left, okay? I'm going to add my filler rod. I'm not touching that cone. Let me make that clear. Outer perimeter, aiming at it, a drop fell in. And if you guys can't see, if some of you need to come over to this side, please do. Now sometimes, if you move your flame away and you touch, this sticks, and that kind of freaks you out. You're like, oh no, and you want to like yank this away real quick because it's stuck, but don't, because then the metal will go flying, it may break off and burn you. So if it sticks, no problem. Just remember, as soon as you aim your flame back at it, it's going to melt off pretty quickly, okay? But sometimes that'll scare you when you're not expecting it. So I'm going to get that little piece that I left on top melted in, and I'm going to go again. I've got my puddle. I'm moving with my horseshoes to the left. I'm going to touch the outer perimeter. Do you guys see the drop falling in? If you don't, you will when you're doing it. Now, if you don't have a good puddle, or you end up losing a drop somewhere else, like that's just kind of on the surface right there now, not really in the puddle, but I can catch up to it and melt it in when I get to it. Watch. There. But remember, it's a little different than soldering, for those of you who solder. Okay, now we're at the end. Okay. Remember to always put your filler rod, that's the hot tip. This is a more comfortable reaction as you're welding to do this. But then your hot part is out here and you're likely to burn your leg. So just always remember to keep that hot point in. And turn the oxygen off first and then the acetylene. Okay, so that was with filler rod.
So does the filler rod ever, like, it never oxidizes?
Rusts?
Or, like, I guess, like, it doesn't oxidize, like solder, or...
like the solder can turn black, right?
Yeah, like, does it get dirty and then it won't work ever?
No, it's just steel, and this is steel, and we're just melting all the steel together. So
The rust will...
it can, yes, but it's not rusty. Like the rust will affect it the same way as it's affecting your base metal, since it's all the same metal. Okay, so I guess with solder, it's a different metal, and so it's reacting different. That's my speculation.
I was curious what, like, the elements of the air, like, over time, like, if this rusts or if it's
It'll
oxidation
rust.
from the air, anything like that?
Yeah, so over time it will rust, but it's not any different than the base metal. So it'll rust together because it's all the same metal. Okay, hopefully that answered the question.
Like,
Okay.
like before, like, I mean, like, kind of like if you had a bunch of this filler rod and you were welding and you left it out and it rusted or something happened to it, and then if you went to go weld it, would there be some sort of issue?
It would probably work, and I've done it, but what you can do is you could just wire brush it a little with a little wire brush to clean off the surface rust. It probably won't be that bad. I mean, if it's really rusty, then just don't use it. But it could potentially make your weld dirtier and more porous, and it won't be as strong if you were working with like a rusty filler rod. But a lot of times it is just surface rust, and so you can just take a wire brush and clean it. The same thing with your base metal. It may have a little surface rust on it, and your filler rod may be fine, and you'll want to wire brush your base metal. Because a lot of times that initial surface rust is really just on the surface. It hasn't like corroded through. And you can also, if it's thicker rust, you could sandblast it to remove it all. Oh, and pliers. Always have pliers. Would you get me a pair of pliers, please? Yeah, thank you. Because everything's really hot. And again, always pretend like everything in the shop is hot, and just get used to touching things like this around the shop. Assume it's all hot. So I'll throw that in the middle, and then we'll just make that's already written there, but we'll write hot, and that's where we'll put all the hot materials so everyone knows. Any more questions? Okay, so the next thing I'm going to show you is welding a 90-degree angle together, okay? Because what we're going to do is we're all going to be making a cube. So we will be cutting out metal for ourselves from the larger sheet that we have outside. Most of you already know how to do that, and you can pick your method of cutting. And the few that don't, I'll work with you on the cutting. Not that we're going to be doing that this second, I'm just giving you the overview. So since we're going to be making a cube, I'm going to show you now how to weld two pieces together in 90 degree, okay? And we'll need another magnet. Thanks. that's fine. I just want these magnets get all, well, they collect all the metal dust in the shop because they're magnets. Okay. Okay. Oops. Okay, so we're gonna weld these two pieces together, but first we're gonna tack them. Whenever you're welding a piece together, you wanna tack everything together first, and then you'll go back and weld. Okay, so I'm gonna line these up.
Is there a certain amount of tack welds you do per so many inches?
Yeah, if you have a long piece, you might go every 6 to 8 inches, because what will happen if your piece is this long and you tack here and you tack here, this will just start opening up on you. So yeah, every 6 to 8 inches you'll want to do a little tack. Since we're working with 6-inch pieces, I'll just put a tack on each end and we'll be fine. If we only tacked one end and we started welding, then it would open up. Because that's one of the downfalls of gas welding, is because your metal is getting so much hotter than other types of welding, you end up with more warpage. So you have to think about that, prepare for that beforehand. So we're going to be making cubes. We're going to tack our entire cube together before doing any welding so that we know that it holds together square. Something that will happen with this piece, I'm going to tack here and tack here, and then I'm going to weld it for the sake of demonstration. But what's going to happen when I weld this, it's going to open a little. So I'm going to lose that 90 degree, okay? So when we're doing our cubes, you'll have 6 pieces, but we'll tack and put that aside, and then we'll tack, and then we will take those that are tacked. These are tacked. And then we'll tack these together on both sides, okay? So that all 4 pieces are tacked. And I even like to tack on the top or the bottom so that we have like 5 pieces all tacked, holding everything square. And then you can weld, okay? Now, if I were to turn this around and weld from the inside, it would actually then close up, okay? So you'll lose your 90 degree one way or the other. Now, this is 1/8 inch material. There's a few different ways that you could weld. We're going to make this so it's like a little valley, right? I'm trying to put these pieces together like this, okay? Sometimes you might want to put pieces together like this, okay, where it overlaps. If you wanted to get like a super sharp corner instead of having a slightly rounded corner, which we're going to have from welding it in the valley. And I do that when I'm using thicker metal. But if you do this is going to be a much weaker weld, because so you're welding here, and then you just don't have as much penetration, and then this can easily just like break apart this way. You'd be able to bend it. In structural situations, of course, you'd weld it from both sides, but we're not going to do that with our little cubes. What we're going to do, like I said, is weld in this little valley, and then we have all this surface, a lot more surface, so it'll be strong, okay? The other thing is when you are welding 1/8 inch, if you wanted to get that sharp corner, you know, you can do this, but because the metal's so thin anyway, you do end up rounding it and melting that little corner over to be a little bit more rounded anyway. For a lot of my furniture, I use 1/4 inch material, and I always do this, the overlap, because I want sharp corners. So in that case, if you do want to do this, what I do is I bevel the edges. I grind off the corners like this. That's much more difficult to do and a waste of time to do with 1/8 inch material, okay? So you could do the overlap, it'll be okay. But with 1/4 inch material, you could just grind those corners off and then weld it, and you still have this corner left, and you have a lot more surface for welding, so it's stronger, okay? So that's all. If you want to do that butt joint or overlap, you'll have to bevel the edges so that you have more surface to weld, Okay, but so for us, we're going to do a little valley. I'm going to try and get it as straight as possible.
I know you're going to tack it first, but do you kind of build up as you go to kind of fill in the whole valley and then keep moving, or do you kind of like go and then keep filling it? I know it's thin, so it doesn't really.
Well, I'm going to do exactly what I did here on here. So this is my seam now. You know how I was saying thinking about as sewing, I just drew a line on that? Well, basically, this valley is my line. So I'm going to have a puddle right here, and then I'm going to move these C shapes, hitting both pieces of metal like that was the outer sides of the line. And then every couple beads adding the filler rod. Okay. Clear? Okay. Sometimes I just want to make sure I'm like, did I really answer their question? Was that what they were asking? Yeah. Okay. So, you guys are not going to forget how to light the torch. Lighting the torch. Oh, and we're never going to weld over the magnet. So I'm going to tack, and I'm going to tack, and I'm going to remove this from the magnet, okay? Because, first of all, this black part right here on the magnet, that's not magnet, that's plastic. The magnet is a circle that's inside of this. And then that just gets melted and smells great. And then it's good for your lungs. And then also the heat is not good for the magnet. So it loses its magnetic qualities. Yes. Like this? Okay, so I do this when I'm TIG welding with a little bit smaller. This gets a little heavy for me. On sometimes, depending on the situation, when I'm in a tight spot, and you guys can definitely try this. Somehow, when I'm TIG welding, that torch is a lot more comfortable for me to hold like this, almost like a pencil. But what I find with the oxy-acetylene torch when I'm welding like this is I don't have as much control over my movement, and it may just be a strength thing, okay? But so I feel like I have more control with what I'm doing like this, and that's because I'm used to this. So in general, I weld gas welding like this, and TIG welding like this. So, and MIG welding like this. So, but we can definitely try that. There are situations where I've been in tight little spots, like inside a piece, where I am welding like this. So, we'll give all of that a try. Mm-hmm. Yeah, like this, I mean? Yeah, and as opposed to like this. Yeah, because you'll always usually have your filler rod here. Okay, acetylene, medium to strong flow. Goggles. Slowly add oxygen until we have a neutral flame. Slip on my other glove. Okay, and I'm ready to go. Now, this is important. If you are, remember I talked about the elbow, lifting up the elbow. If you're like this, you're going to only heat up the steel that's on this side, okay? And this one's going to melt, and it may melt and overlap onto this steel behind it, but it's not going to really be welded, okay? You want to make sure that both pieces are the same color and melting at the same time. So you may have to go back to both corners. But you see already how they're melted? They actually melted together before I added filler rod, but I like to add a little filler rod for extra security. So I know I have a good bead there. Then I'm going to go over to this side and do the same thing. And I'm trying really, you know, with the other tack, I was really trying not to aim too much at the magnet, like I said. And also with gas welding, it tests your patience. Like it teaches you how to be more patient, because I think in general, when you think about welding, you think, oh, this is like going to be a faster process. And then you're gas welding and you're like, oh my, I'm waiting for it to melt. It forces you to be patient, because you have to be patient if you want it to come out right and actually be a weld. So now that both pieces are tacked, I'll take my pliers, and I don't want to lift this off the magnet like this because they're only tacked and that will bend, okay, and open up. So I always try and grab it from the seam and lift it off perpendicular to the magnet so I don't lose my 90 if it is in fact 90. The magnet's probably a little warm, so we'll set that aside. So now I have this tacked piece that looks like a 90 degree. I don't need to raise this up on angle bars because it's not flat on the metal. So I can weld that right on the table. But a little trick that I do like to do, because gravity works in our favor, if I'm welding from right to left, I like to raise my piece up a little bit on the right because it makes a good looking weld, right? So if you have this liquid and you have a little gravity flowing down in the direction you're welding, it just makes it look nice. One other thing I should mention, when you're tacking sometimes, you see how I was getting the two pieces to both be melted, same color, same time. Sometimes, because of gravity, since we're on the subject, the drop on this side will start going this direction, and the drop on this side will start going this direction, and you'll end up with a big hole. But remember that this is liquid, so what I start to do when I get both of these corners melted is I actually use the tip and I go in a quick little circle because it's liquid and you can actually push the drops around to make them join if they start going in the opposite direction. There's that little trick, even if they're not going in the opposite direction. Once they start to melt, you do that, it pushes them together. But if they start going in the opposite direction, even the little circles aren't going to make them join. So I get this, I really get the filler rod in there too as well, and do the little circle, add the third drop, because if you think about it, if you had a drop of water here and a drop of water here, and you put a third drop, it's just going to join, right? So think about it like that, like liquid. So that helps. Okay. So now I'm going to weld that together. Oh. We're going to light the torch again. A little bit of acetylene. Turn the striker away from you. That was a little bit. Adjust the acetylene, medium to strong flow. Goggles. And slowly add oxygen until you have a neutral flame. Slip on your other glove, and we're ready to go. So now, you know, if it is too low for you, for the taller people, we can make something or make a frame or something that would raise it if you don't want to sit, okay? All right, so I'm staying very still. I'm not going back and forth yet. I'm just trying to get the color. I'm starting right back on that tack. I'm not starting to the left of the tack because I want a nice uniform row of welding beads, okay? So, okay, I have a puddle. Okay, and now I'm going to start with the horseshoe shapes going to left. But I'm making sure that I stay sort of in the center of the valley. I'm going to touch the outer perimeter of a puddle, make sure I see a drop fall off, and then I'm going to keep going for a couple more beats. And then I'm going to do it again, not letting the cone touch the puddle or the filler rod. I saw the drop fall off, and I'm going to keep going. My torch is angled in the direction that I'm welding, so I'm always heating up the space in front of me. So should I stop for a second and it cools off, remember, I'm not going to start there. I'm going to start behind the last bead because I want it to be smooth. Now, the other thing is, if you see the valley, I'm going to do a little bit without the filler rod. You see how if everyone can come in closer, you see how there's a seam, like the vertex, right? Right in the middle of that valley. I'm looking for that to close up. You can see both pieces of steel are melting. I'm going back and forth. And it's like a puddle, but what happens is it just sort of melts together and you see it close up. If you go too fast, you could potentially like skip a part and end up with like a part that's not sealed up. You see how there's still a valley there? So I'd want to come behind that. I want to see that close up. And you see, you can go through this. This is thin metal. You could get through this the whole way without even adding filler rod. It's such a clean edge. But for the sake of practice, we'll add filler rod. And as you guys are practicing, you have the option. You can do a little bit with filler rod or just get the motion of welding down without the filler rod, and the next time add filler rod, but I want to show you. Okay, so when we get to the end, remember how I'm going to lift up? The other thing I also do is I usually add a little extra filler rod at the end because you kind of risk getting a little divot there. There. Hot end in. Turn off the oxygen first, then the acetylene. Make sure it's off, and then hang it over the edge. And there. That's it. Now it's welded. And that goes a lot more smoothly, like I said, than just welding on a flat surface. But that's really good practice to weld on a flat surface because it's a little bit more difficult. So then when you get to welding two pieces together, you're like, oh, this is easier. Any questions? The other thing that I love about gas welding is there's not a lot of spatter. Spatter is all these little metal balls, and anytime that you're out now and wherever you are, in a coffee shop or wherever, and you see something that's been welded, like go look at the weld and touch around the weld, and if you see like little spatter, it's probably MIG welded more than likely. People would never get work done if they only did gas welding. But it's beautiful. So like a lot of my sculpture, I end up gas welding and I leave the welds because I want to see the welds. TIG is nice like that as well.